Hi, I'm David Wiens.
And this is Max Trussell. We're going to be doing the double replacement reaction. First, we'll walk through the experiment in late night labs, and then we'll explain the equation through ionic formulas.
Alright, so the first thing you need to do is take two 50 milliliter beakers from the container shelf and bring them onto the workbench. So that is one 50 milliliter beaker, and then we'll grab another. The next step is to add 15 milliliters of a 1 molar solution of sodium hydroxide. That means for every 1 liter there is 1 mole of sodium hydroxide. So we'll go to materials and grab that from right here. And like I said, we need 15 milliliters. Alright, and the next step is 6 milliliters of nickel with a charge of nickel 2 plus chloride solution, and that is going to be right here, and we need 6 milliliters of that in the other beaker. Alright, now we have the two beakers full, one of 15 milliliters of sodium hydroxide, 1 molar solution, and the other of 6 milliliters of nickel chloride. And we're going to pour one beaker into the other. Pour all. Alrighty, now we can observe the contents and see that while before both solutions were aqueous, now there is one solution that is aqueous, and there's also a solid precipitate, which you can see in the green dot right there.
Alright, so that's the experiment, and now you should switch over to the PowerPoint. Alright, so we have the combination of sodium hydroxide, which is an aqueous solution, with nickel 2 chloride, which is also an aqueous solution. And we demonstrated the balanced chemical equation on the top level, that is 2 moles of NaOH, which would be sodium hydroxide, mixed with 1 mole of nitrogen chloride, which is also aqueous, to form 2 moles of sodium chloride, which is an aqueous solution, and 1 mole of nitrogen hydroxide, which is the precipitate, meaning that it is a solid. And then we moved on to the ionic equation, which means we broke down the chemical equation into its ionic components. So that gives us 2 sodium ions with a charge of +1 and 2 hydroxide ions with a charge of -1, with a nickel ion with a charge of +2, plus 2 chloride ions with a charge of -1, and this yields 2 sodium ions with a charge of -1 and 2 chloride ions with a charge of -1, and then the precipitate, which is nickel hydroxide, which is a solid. So then we removed the spectator ions to receive the net ionic equation, which is simply 2 hydroxide ions with a charge of -1 plus 2 nickel ions, or no, 1 nickel ion with a charge of +2 to get nickel hydroxide, which is the solid. So the sodium hydroxide and nickel chloride reaction is a double displacement reaction, meaning that one reactant is replaced by part of another reactant. Double displacement reactions take the form of AB plus CD yields AD plus CB. In this case, the nickel ion switches from the chloride to the hydroxide, and the sodium switches from the hydroxide to the chloride.
Alright, once again, that was David Wiens.
And Max Trussell.
And there you go, sodium hydroxide and nickel chloride.